helping you with Acorn and RISCOS computing.
Although my ears are bigger than I expected them to be, it's kind of getting stuck there. It is, I think that's what it is. And I seem to have some sort of automatic thing going off on my slides, but I'll work that out later. Okay, blimey, that's bright. Feels like an interrogation. Okay, so I'm going to tell you some stuff that we've been working on for the past year or so. Some of it you might know about already. The first one is FAST. So FAST is, we determine that as fast access storage technology. So it's a true SATA-based storage technology. In the past, we've had a few machines that have been SATA over USB. And as we know, we've only got USB 2 speeds, so they've come in quite slow. With the fast stuff, we decided we wanted proper SATA, and we connect that up with the compute module using the PCIe port on the compute module I/O board to get it to do that. And we opted to use ADFS. We could have used SCSI instead because ADFS gave us the option for 4 SATA ports. So with our fast machines, there is the capacity. It will normally come with 1 or 2, but there is the capacity to run up to 4 SATA drives, be they SSDs, optical drives, or whatever. The issue with that is one of the ports is external, and bizarrely it's port 0, so that kind of takes precedence over the others. So if you plug something in externally prior to boot, it will try and boot from that drive. So if it's not a boot drive, it kind of won't work at that point. And the whole thing is based around the Raspberry Pi Compute Module 4, and with the exception of Chris, at that point in time, people weren't doing much in our world with the compute module, but it was the one that gave us that option to do that. We call it fast, which is a bit of a potentially controversial, because it is possibly still the fastest RISCOS computer in the world that we know of. The disk speeds that we're getting, combined with the speed of the processor and the speed of the RAM, mean that there is nothing that currently competes with that. We did think when we were developing our NVMe drivers late last year, earlier this year, that they might take precedence and might run faster, but for whatever reason, they've currently turned out to be slower. There may be some optimizations that we can do in there. We looked at background transfers to see whether that would work, but we kept getting stuck. And when we inquired a bit further, we were told that the last machine that actually did background transfers for anything was the Ionics, to try and speed up their disk access. So we've kind of left that as it is. I'll come on to that more when we talk about NVMe. With SATA, though, we're currently, and fast, we're currently exceeding that. And it looks like we're about half the speed of direct RAM access. The possible limiting factor now is the speed that FileCore can go at, which kind of means that it's unlikely, I think, that we'll get anything faster than fast. I wish I'd called it something else. As it stands, and coupled with the speed of the RAM and the speed of the CPU, we have overclocked it to 2.28 gigahertz, which is excessive. It gets very warm. You might not want to do that without some sort of decent fan and heat sink, but at 2 gigahertz, which is what we clock it to as stock, a chunky heat sink and everything's pretty good. Some of the other features that are in there as standard is the 4K screen resolutions. So as you'll know, the Pi will do up to 4K, and it'll do that comfortably at 30 hertz. It might do it at 60, but we're back to like Panda board territory where things start to tear a bit. generally 30 hertz is fine for most things. We don't have that option still to have the second HDMI port, and with the number of machines that have 2 HDMI ports these days, it seems like there's an opportunity there that's going begging. It is upgradable. So the standard Fire machine that's on our desk today comes with 2 gigabytes of RAM. If you want 4 gigabytes of RAM, you pop the compute module out, get a new one with 4 gigabytes of RAM on, just drop it in place, and it just does that. There's no configuration needed. It will just work. It'd be advisable to take the heatsink off though and put it on the new one. But apart from that, it will just work straight out of the box. And I'm led to believe that some of the work to allow us to access 8 gigabytes of RAM has been fed through. So that may well be possible, although what you're going to do with 8 gigabytes of RAM is way beyond me. That 4 gigabyte RAM disk, I suppose. And there are several Linux options for fast. One of the issues we've had is that would tend to require a replacement of the SD card with a Linux-based one, or boot from a separate drive in some way. The SATA controller on the board that we use to control SATA is not particularly well liked by the Linux kernel that we get as standard. So trying to do something like we did with EDOS or booting from a SATA drive just fails because the kernel can't see the SATA controller, doesn't know what to look for, and doesn't kind of work. But from an SD card and then having a separate hard drive inside that you run from later is fine. Some real world examples of what we can get fast to do. So it will compile a ROM in about 3 minutes 20 seconds to a disk. It will do it in 2 minutes 46 seconds from a RAM disk, but 3 minutes and 20 seconds on a disk is shifting for people that built ROMs on Beagle boards and things like that, where you went and had a cup of tea, cooked your tea, ate your tea, washed up, took dog for a walk, and you'd still got a bit of time before it had finished. That 3 minutes and 20 seconds is pretty good going, and I don't think there's anything that's comparable, not the titanium or anything that's comparable in terms of that speed. Even the NVMe stuff is not coming in at those kind of speeds. One of the real world examples from the RISCOSM guys was we asked them to test it, push it through its paces with their map conversion to the point where they just bought one. They said it was twice as fast as their IMX-based system in processing that data. So I just didn't get to see that come back. They just kept it. And we can do 4K sector drives with fast. So we have built one machine just for, let's see if we could, with 6 terabytes of storage over 3 disks. It did work. There is no point. I don't know what you're going to do with 6 terabytes of storage. As I've been saying to people outside, if you've got a 2 terabyte disk, that's everything ever produced for RISCOS 3 times, and you've still got space. 6 terabytes, it's a lot. You're not going to need that anytime soon. But it's capable, so sometimes it's worth it. Some considerations then. The fast machines don't have any USB 3 ports. Now, we currently know that for us, USB 3 ports don't work. They work as USB 2 speeds, but not as USB 3, but there is a bounty for that's sitting there begging. But part of the deal with the compute module and the PCIe stuff is it has to remove the USB 3, and that's the same for us, that's the same for Linux. On a Pi 4 itself, the USB 3 chip is just plumbed in to the PCIe lines. On the compute module 4 board, that's no longer there. So it leaves us with 4 USB 2 ports as standard. For most of us, though, that's going to be more than enough, and the disk speed makes up for that. It does need a custom ROM. We're hoping that now 5.30 is imminent this afternoon, I think, that we'll be able to get round some of that. But for the time being, we had to roll back the kernel to an earlier version around sort of January, February last year. So even with our current builds, the kernel is from January or February last year. Because not long after that, some stuff changed in the SDIO things, which meant that we'd suddenly gone from being able to use any old SD card to only a SanDisk Edge SD card. And then suddenly they started to fail because not all SanDisk Edge cards are the same. So we had to roll back again and say we're going to have to stick with this kernel there. And that affected our ability at that point as well to do things around using eMMC. With the changes that they've made to the SDIO stuff, we're hoping now it'll be easier to use any old SD card and eMMC out of the box. There was a point where we were struggling with the number of Compute Module 4s that were available. As the Pi 4 stuff recovered after the chip shortages, the Compute Module 4s seemed to take a while longer, but we're now at a point where most of the models that we'd want are available sort of fairly readily. There are some that are a bit rare, but most of them are knocking about. Some other considerations then, it does have that easy compatibility with other boards. If your board's got a Compute Module 4 slot and a PCIe slot, in our experience, if you plug it into that board, it will just work. It's not looking for anything particular to the Compute Module 4 I/O board. That's the one that we choose to base our stuff around. But there's definitely a WaveShare board with a Compute Module 4 slot and a PCIe slot that just works out of the box. It's cheaper by far, I think, than any other SATA-based RISCOS system that's around because we designed it that way. We could have designed, and we talked about designing a mini ITX motherboard from scratch, and that would have cost us 150 quid just for the motherboard. For the quantities that we need, we're not going to be a priority. The Compute Module 4 I/O board is 40 quid. It made more sense to build an adapter for a standard board rather than to build our own board to do that. It has that potential, as I said earlier, for dual screen options in future. I do think there's a bit of a potential cash cow for somebody in there to do that with everything having double HDMI ports. And as I said earlier, it doesn't work with eDOS. If the 8GB RAM thing is true, that's great. That means that'll be useful for us. Currently, if you're going to run Linux on it, then that 8GB of RAM thing would also be useful there. It does as well just utilise the standard wireless chip, should that be of any use to anybody at this point. And we've purposely picked cases that, although they're metal, have the connector for an external antenna if people want to do that as a bit of future-proofing. So some recent developments. As I said, we've managed to do big disks up to 2 terabytes, and that's full file core use. So that's not partitioned so that half of it or 3/4 of it or whatever is FAT32. That's the full disk. We have a special formatter that does that, and in a bizarre twist, that formatter only works under Linux. So we have to plug the disk into a Linux machine, format it to file core, and then put it back into the fast machine. We did some work to build in CDFS soft TAPI so that we could use SATA optical drives, and that's gone into the ROM now as well. And there's a bit of an issue there that sometimes video discs don't show up as video discs, and we're trying to work out why that is, but we haven't done that as yet. And we did have a time where the big discs, the 4K sector discs, couldn't be seen at the same time as ordinary 512 sector discs, but we've resolved that issue. And we've got some software that we're waiting for 5.30 to roll out that will do any firmware updates, be that the ROM or any of the other Pi firmware stuff, over the air. A bit like the IO watch on the Ionics, it'll tell you that there's an update available. It'll give you an option to update it. It'll give you a checksum to make sure that it's going to work. It will then update it and save the old one so that if you want to roll back to the one you had before, you can do that. We've been testing that for some time, but we decided to wait for a big ROM update to get that one to work. Some future developments we're looking at the moment is we've been looking at a support board that would just plug into the compute module I/O board so that we can plug in a standard ATX power supply and have all the functions that we'd normally expect in a PC case just working out of the box. We looked at, discussed that in terms of whether we'd want some sort of internal USB hub or ports as well to give us more USB ports. The jury's out on that one. It has an onboard real-time clock and fan control that we currently can't use. I know Chris has done some work to get that to work. It'd be nice for us if we could use the ones that are already on the board, fairly straightforward, rather than having separate ones. And then, as I said, that improved eMMC support, which should come with building on top of 5.30 rather than 5.29, based on January last year. So in terms of where we were going with things, so we did some work early on multi-format partition support, and then realised that John Abbott was doing better work on multi-format partition support than us. Great, let's not reinvent a wheel for the sake of it. There are other things we can look at. So we've just said if you want multi-format partition, use John Abbott's partition manager. eMMC support is almost there based on that 5.30 stuff. And there are some issues with GPIO support. The way the compute module board works, it takes some of the GPIO lines to control the camera and the internal display stuff. And we're trying to work out how to switch those back, because we know they can be switched back. We just hadn't worked it out. And then we were going to build in NVMe support, but that became a bit of a side project. And we completed that anyway and produced, as of February this year, the free NVMe stuff that was adopted by RISCOSopen and is now on their website for you to use as standard. The difficulty with the NVMe stuff when we were doing that is you either have the NVMe stuff or you have the SATA stuff. There is no option to have a combination of both, because you have to unplug the SATA card from the PCIe slot to plug in the NVMe drive. Onboard real-time clock support, we've got quite a bit of work to do that. The power control stuff, there may be a software option, but we'd prefer to do it through the add-on board that controls that better. And then, as I said, the over-the-air upgrades, we're 95% complete. We're awaiting eMMC and 5.30. So that's where we are with Fast. The pricing on those is the core model, which is just the PCIe board, some SATA cables, and an SD card to get you going, is 99 quid. That gives you access to any developments we make in future on that. The Fire system, which we've got 3 available outside, comes with 2 gigabytes of RAM. It's a complete system ready, 250 gigabyte SSD, everything you need. You plug it in, it just works. For those of you who want the real super duper absolute systems, then there's an option for a Fury, which is 4 gigabytes of RAM, a 1 terabyte file core drive, and all the bits that you get with Fire. And then finally the disk, because we have to use the special formatter. If you want a 1 terabyte disk, we can do that for your Fast system only, for about 99 quid. So free NVMe is the offshoot from Fast in terms of getting NVMe drives to work. It was a side project. We did it in collaboration with those people and RISCOSopen, Stardust Software Entwicklung. I'll go for that. And RISCOSopen, and as I said, Rule have adopted it. It's built into their repositories. You can look at that now. You can see what we did, how we did it, and they allow you to download the pre-built binaries from the Raspberry Pi section on their website to go. All of our NVMe systems outside are based on that and work particularly well at that. It's been useful to us to have rules oversight and assistance in that, and they were very good in getting us to do that. And currently that only works on the Raspberry Pi 4 compute module, or Pi Compute Module 4, but we're hoping to bring that to things like the Titanium and possibly, I guess, the Pinebook Pro, although I doubt we'll get access to the source on that to see what we'd need to do. And it's got its own, it may well be a duplication of effort. It connects the NVMe storage device, which, if you know, is just a relatively small card with a few chips on, directly to the fast PCIe slot. And it's opened up a range of different boards for us to use. So there are lots of Compute Module 4 boards with NVMe slots because they're so small and compact that are now useful to us where they weren't before. It's almost as fast. We thought it would be faster, but for whatever reason, it isn't. And again, we've got the ability there to use 2 terabyte drives under file core using 4K sectors. So the NVMe systems that we've got on show today, we've got a fast NVMe. The reason being it will benefit from any of the hardware developments we do on fast. So it's a familiar shape. It's in a black aluminium, an old Mac Mini style box. It's got the standard set of ports, 2 HDMI, 2 rear USB, 2 front USB, gigabit Ethernet, and the internal GPIO. And it comes with a 256 gigabyte NVMe disk as standard. The specs are, it's got a 2 gigahertz CPU, 4 gigabytes of RAM. That puts it out in front of the Fire, which only has 2. A 32 gigabyte eMMC, Wi-Fi built in, and a real-time clock. And it is our premium NVMe machine for running RISCOS, but can use Linux and can use EDOS in the way that the fast machines, the SATA-based ones, can't. We've got the Pyro Cube, the really, really tiny one that's on our stand. The potential issue with this is you're going to put it in a drawer and not be able to find it again, along with all those Pi Zeros that you bought thinking, oh, I'll do something with that one day. It is pocketable. It is absolutely tiny. It's basically the footprint of the compute module plus a little bit, and internally it's stacked in 3 layers where there's the NVMe drive at the bottom, the compute module, and then some of the input-output stuff. It's got a full range of ports, so it's got 2 HDMI, we can only use 1, 2 USB, gigabit Ethernet. The GPIO is exposed around the back as well, and it does have the port for an SD card, but given that we supply ours with eMMC, that port is redundant at that point. And it comes as standard with a 128 gigabyte NVMe for RISCOS to use. It's such a small machine, it's so low power, you can plug it in to the USB port on another computer and it'll work fine. That's enough power for it to generally get by, even though the booklet will say it'd be really nice if you had 5 volts and 4 amps, it will run on another USB port from another computer. And Chris, again, did some work to get that to boot from eMMC or NVMe with a fix, but it will also be compatible with EDOS, so it will run Linux on that at the same time. I'm not going to tell you about the Venom because we've sold out. So there doesn't seem a lot of point. We don't have that available today. It's basically the same spec as the fast NVMe in a more compact case. And it has a natty little OLED screen on top to tell you things like what the temperature is, what the CPU is running at, how many days it is till Christmas, or when your partner's birthday is, whatever you want. You can program that yourself. We use it for standard computing stuff, but how many days till Christmas always frightens people. The other machine that we brought a stock with us today, and we've got the display model left, is the NVMe. You might be able to see what I've done there, which is a small, compact electric blue machine. We because of the way the lid is based on that is quite a thick acrylic, we've downclocked that to 1.8 and used a standard heatsink. If you used a heatsink with a fan, you could clock that up as much as you wanted, but we kind of leave it there. That feels comfortable to us. It's got 2 gigabytes of RAM. It hasn't got 32 gigabytes of eMMC, that's my mistake. It's got a 32 gigabyte SD card. It does have Wi-Fi, and it's got the standard range of ports. The difference being it's only got one HDMI port. They've sacrificed one in favour of 2 extra USB ports. It does, though, have a USB-C port for both data and power in. That makes life easier if you've got all those Raspberry Pi 4 power supplies knocking about, although it does have a barrel connector for a wide-ranging supply as well. And that comes with a 128 gig internal storage NVMe drive there as well, which again is expandable up to 2 terabytes, but why? The case is quite striking if you look at that, and I think we worked out it was about 1 litre, but don't pour water in it to see, because there'll be a bang and a flash and that'll not work anymore. And it's got a lovely little pop-off lid that you push a little button on the bottom, the lid pops up, and you can access all the components inside. One thing that we haven't talked about there is there are a number of extra connectors inside that we don't normally see. We don't know whether they work for us, but if you're that way inclined, that might be a useful thing for experimentation. 3 minutes. Blimey, I'm only halfway through. No. So in terms of the pricing then, the fast NVMe machine is $279. That is our top spec machine. It's got everything we need. The Venom, when it's available, would be $249. The NVMe would be $199, and the PyroCube, because of the way we've done that, is $179. There was a review of the original PyroCube in Archive magazine where the reviewer said you can't actually build it for that price. And there is an optional real-time clock for that Chris has built that does make it more useful. There is one inside, but again, it's one of those chips that we can't access. I'm going to whip feverishly on then to what we're going to do in future. So we've got the Rhodes scheme, where if you're an active developer of any description, if you're developing things or you've developed things in your past, you want to get back to it, the scheme is basically a discount scheme. So we're aware that for some people it might be difficult to get back into this because of the costs that are involved. So we have once you've registered, we have a separate website that says, here are the same things that we normally sell, but at discounted prices, as long as you are developing some software for the rest of us to use. That doesn't necessarily have to be free software. If that's commercial, that's okay. But as long as you're doing something, and we'll make some checks about that to make sure that those things are there for you. And it gives you that opportunity to buy things at a reduced rate. And then some other things that we're looking for in future is incorporating eMMC into all of our fast things, trying to make as many machines as we can user upgradable. And we've done some work around integrating Linux apps into RISCOS at one point, and we'll do a bit more work on that. Using a separate computer, but just pulling up, instead of the whole Linux system, just OpenOffice or just Inkscape. We'll look at using other platforms that benefit RISCOS. The Raspberry Pi is great for Linux. There are other things that are better though, and if we can get those to work alongside, that'll be great. And then looking at more hardware that we can develop for use with RISCOS. There's a list of websites there that you can look at to find out all the things that we've talked about. We've got leaflets that tell you all this on the desk as well. And there you go. That's it. Thank you very much. Anybody got any questions in the 5 seconds I've got left? Yeah.
Can you load 5.30 on a fast?
Not yet. Because of the stuff that I said earlier, we need to change the HAL, but we're going to release a 5.30 as soon as we've done that work.
Okay, thank you. Will the fast take any of the Wi-Fi?
Yeah. again, we need to update that to the 5.30 stuff, because that was the bit that broke what we were doing. It was some of the SDIO stuff that uses the Wi-Fi. But once we've resolved that, Wi-Fi should just work as it does now.
And so is it for the user to contact you, or will you contact all fast users?
When we've got a list of everybody who's bought one, and we'll mail out to say, we've got a new ROM.
Right.
Here you go, download this one. This will enable Wi-Fi.
Great.
And all the other things.
Thank you very much.
Any others? That either means I was crystal clear or you're utterly confused. I'm not sure which. Great. Thank you very much.